Hi everybody, I need you to find your Apply the Pythagorean Theorem on the Coordinate Plane Lesson 27 Notes template. It starts with question 1, asking to apply the Pythagorean Theorem to find the distance between the 2 points in a coordinate system, and when necessary, round your answer to the nearest tenth. So we can see the 2 points are here and here. And I've traced over that right triangle. We want to count the lengths of the sides that we can count along the coordinate plane. The only sides that we can measure the distance of accurately right now are the legs of this right triangle because they follow the grid lines. So the bottom leg from the point on the left measures 7 units on the coordinate plane. And I'm just getting that by counting the blocks across, 1, 2, 3, 4, 5, 6, 7. And then the leg that is going up measures 8 units. And like I said, those are the 2 legs, so those are our A and B values in our Pythagorean theorem. We're trying to find the hypotenuse, which is C. So I've plugged in what I know about this right triangle to our Pythagorean theorem. We always start with the formula a squared plus b squared equals c squared. We have the legs, so I plugged in 7 squared and 8 squared. I'm going to find those values, and then I'm going to find their sum to be 113. And I am trying to find what C is. So to undo the power of 2, I'm going to take the square root of 113, which is about 10.6 units. You'll notice I'm still putting the units on my answer even though I don't have a set unit like feet or centimeters. And you'll notice I'm also using the approximately equal to sign because I'm rounding to the nearest tenth. On question 2, it's a very similar question, except we don't have the right triangle drawn for us. So we know that we're using Pythagorean theorem, and we know that we want to measure the distance from point A to point B. The reason you cannot count blocks is because the diagonal length across a block is not the same as the height or width of each of those blocks, and so it can't be measured by just counting blocks across. We want to find the right triangle with A and B as its hypotenuse. So there's my right triangle. I'm going to label one leg of this triangle is 4 units, and I got that just by counting from the base of my right angle to point A. And the other leg is also 4 units. So this is not only a right triangle, it is also an isosceles right triangle. So I'm going to find the length of hypotenuse AB, which is our C in our Pythagorean theorem. By using the Pythagorean theorem, a squared plus b squared equals c squared, we have the lengths of legs of 4 and 4. Plugged in is 16 plus 16, which gives me a sum of 32. To undo the power of 2, I'm going to take the square root. And the square root of 32 is not an exact integer. It is about 5.7 units. And we can always use a lowercase u to stand for units. In example 3, we have another right triangle. This one we are starting at the ordered pair -3, 5 for the top. And for the other point of our hypotenuse, we're at the ordered pair -5, -5. Make sure that you are darkening the right triangle on your notes template and that you are labeling each of the legs with their length in the amount of blocks on your graph. The bottom leg being 2 and the side leg measuring 10. And then again, we're going to find C. Filling in the work here, we've got our Pythagorean theorem always as our first line. Plug in of one leg of 2 units, one leg of 10. Their squareds give us 4 plus 100, and their sum is 104. To undo the power of 2 on the hypotenuse, or C, we need to take the square root of 104, which is about 10.2 units. For example 4, we want to find the distance between the ordered pair -2, -4. So go ahead and plot that point on your graph. And at the ordered pair 2 positive 4, pardon me, so to the right 2 up 4. And then what you want to do is you want to draw the hypotenuse, the diagonal distance from the first point that you plotted to the second point, and then you want to draw in the right legs that will form the right angle. So there's my right triangle there. I want to label what I can find from my graph just by counting blocks. The bottom base is 4 units long. The side base or leg of the right triangle is 8 units long, and I am finding C. So let's plug that into the Pythagorean theorem. So here you'll see my formula, my plug-in, and my work line. The sum of the squares of the two legs are going to give me a total of 80. And to undo the power of 2, you need to take the square root of 80. Remember, you're not dividing by 2 to get rid of that exponent of 2. C is going to be approximately 8.9 units. So this time we're finding the distance between the ordered pairs 0, 7. And the way to remember what you're doing here is the 0 is for the x-coordinate, so you're not moving left or right when you're plotting this point. You're just going up 7 on the y-axis and making a point. And then we're going to plot the point -5, -5, which is to the left 5 and down 5. Then you want to use your pencil and possibly a ruler, and you want to connect those 2 points with the diagonal representing the hypotenuse of that right triangle, also drawing in your legs. And yours will probably look a little bit more exact than mine with a stylus. You want to label the legs that you have. The bottom base leg is 5 units long. And again, I'm getting that by just counting the blocks across from the bottom point of my hypotenuse to where it hits on the y-axis, 5 units. My side leg is 12 units in length, and again, I'm finding C. So go ahead and plug what you know into the Pythagorean theorem. So here's my formula line, my plug-in line, and my work line. I'm going to find the sum of 25 and 144 is 169. And in case you're not seeing it, that is actually a perfect square. When I take the square root of 169, I'm going to get an integer answer of 13 exactly. So I'm not switching to squiggly equals, and I'm going to label it with units or a lowercase u. For question 6, they're asking for 3 parts on this problem. The first part is we just need to plot the points that were given, x, y, and z, and it's important to label them with the correct letter. Point x is at -3, so to the left 3 and down 2. And we're going to label that x. Point y is to the left 3 but up 4. And we're going to label that. And z is to the right 5 and up 4. And we're going to label that. Now, if we had plotted 3 points and not formed a right triangle, we would not be able to use Pythagorean theorem. But because we are finding the length of a missing side in a right triangle with a right angle at angle y, point y, we can use the Pythagorean theorem. We want to find the lengths of the sides of the triangle, and 2 of those, the legs, yz, and yx, are just counting blocks on your graph. The length from point x to point y is 6 blocks long, and the distance from y to z is 8. And we are going to find C. So here you'll see my formula line, my plug-in line, and my work line. 36 and 64 give me a sum of 100. And then we need to take the square root of 100 to find that the hypotenuse is exactly 10 units long. For part B, we want to find the perimeter of a triangle. And I've replicated the triangle here, but you can just look up further on your graph on your notes template. For the perimeter, we want to use the formula P equals A plus B plus C, where we're plugging in everything we know. We knew the two legs were 6 and 8, and we just found that the hypotenuse, or C, was 10 units long. Finding their total, we get a total perimeter of 24 units. You can use the word units or a lowercase u. To prove that triangle XYZ is a right triangle, what we're going to do is essentially do a check using Pythagorean theorem. We should be able to plug in what we know about the right triangle and the lengths into the Pythagorean theorem, and it should equal itself on both sides. So plugging in, we've got 6 squared, 8 squared, 10 squared. This gave us 36 plus 64. 100 squared gives us 100. Finding the sum on both sides, you should be seeing that we get the same sum on both sides, proving that it is a right triangle. Now taking a look at example 7, it's very similar to example 6, where we are doing the 3 parts. The first part is to plot the ordered pairs A, B, and C, so go ahead and do that. So I went ahead and plotted the points A, B, and C, labeled them, and connected them to form my right triangle. I want to make sure that I'm always labeling the right angle, which helps me to identify which sides of the triangle are my legs. The side AB is a leg, and we can count the length in blocks along our graph to be 12 units long. Side CB is also a leg, measuring 9 units long. Use the Pythagorean theorem to find C, the length of A. So I've got my formula line, my plug-in line, my work line. I'm finding a total of 225, which is a perfect square. To undo the power of 2, I'm taking the square root of 225. So the hypotenuse should be exactly 15 units long. To wrap up this last example, we want to find the perimeter of the triangle. I've replicated the triangle again on my paper. I want to use the perimeter formula for a triangle, A plus B plus C. Plugging in what I know the values of 9, 12, and I just found the hypotenuse of 15 units. Our perimeter is an exact value of 36 units, so we are not going to change to approximately equal to. For part C, you're just going to use the Pythagorean theorem, plug in what you know, and just like a check, we're looking for both sides of the equal sign to equal each other. 9 squared plus 12 squared should equal 15 squared if this is truly a right triangle. That gives me 81 and 144 equals 225, and 225 equals 225, which checks out.